Only 3 more on this, and then I figured we could just get as far as we could on the next one.
Okay, yeah, let me grab the snip of this. All right, yeah, go to the next, please. All right, I got it. You're gonna go to the next. Okay, so you want to start the next one? Or you want to wait to do that?
Let's wait, just knock these ones out and
All right, sounds good. All right, be right. All right, just a moment. The button's clicked. All right, we'll be sharing my screen here and we will get started.
okay.
All right, a fence must be built to enclose a rectangular area of 20,000 feet squared. Material, so we start area is 20,000. Fencing costs $2 per foot for 2 sides facing north and south. So we can say $2, $2, $4 on the other side. Find the cost of the least expensive fence. So we'll go X, X, Y, Y. The area is X times Y, and that's 20,000. That's equation 1.
Okay.
The cost is the price times the length. So 2X plus 4Y plus 2X plus 4Y, which equals 4X plus 8Y.
Okay.
And so we got Y on the left here. We can solve for Y. It's 20,000 divided by X. And so we'll take that and put it into this equation here. So we got 4X plus 8 times 20,000 over X. And then this is where you have to be able to take your derivative. So the derivative of 4X is 4. This thing on the right here, if I just kind of rewrite it off to the side, it's 160,000 times 1 over X. So the derivative, if you recall, it's still power rule. It's X to the minus 1. So you bring that minus down. So it's minus 16,000, 160,000 X to the minus 2 power. And you then set this equal to 0 and solve for X. Like that. So to solve for 0, or solve for X, sorry, by setting it equal to 0, you move this 160,000 over X squared to the right. You multiply both sides by X squared to clear that out. And so you're left with 4X squared equals 160,000. And then you divide by 4. This does not work out nicely. Maybe it does. Yeah, it does. Okay, so take the square root of both sides. Square root of 40,000 is 200. So X equals 200. So you gotta be really careful about like what it's actually asking for.
Okay.
I don't remember because I didn't read it that closely, but it says the cost of the least expensive fence. Okay, so they actually want the cost, which means you need both X and Y. So you have to go back to this here. So Y is 20,000 divided by 200. So it ends up being 100. So the cost is 4 times 200 plus 8 times 100, which equals 1,600.
Okay.
That's your final answer.
That's good.
So there is a shortcut to this in your review, which is that the one length of one side is always half the other. you can sort of manipulate this to get that as well. And some of the numbers. We'll get to that though, when that's the right time.
Okay.
All right, a rectangular tank with a square base and an open top. You have like an art degree to do these problems. So square base, that means that these are the same and the height is y. The top here is open. I always feel like that's a weird thing to have a box with an open top, but nevertheless, that is what you have here. The square base is really important. That's why they're both the same, x and x. So the volume of this is x times y, or x squared y, and they're giving you the volume. They're telling you it's 5,324 feet. The surface area is all the sides except for the top. So you sort of want to do it as like bottom, and then you got the front, the back, the left, and the right. All right, so the bottom is x times x, or x squared. The front, and it's okay to relabel these, the front is xy, the back is also xy, the left side is also xy, and the right's also xy. But there's no top.
Okay.
Any questions, thoughts on that?
No.
So that's x squared plus 4xy. So the general procedure for these is you get two equations, one that you're going to optimize. You have to substitute in for one of the variables so that you get it down to one variable so that you can take a derivative. So we're going to solve this on the left for y, solve for y. Y equals 5,324 over x squared. So that's x squared plus 4x, 5,324 over x squared. And when you simplify, I'm going to grab a calculator here for this. 4 times the 5,324. I can get my calculator up. All right. So there's a plus there. 21296 over x. So this top x cancels one of the bottoms. And then now you're finally ready to take a derivative. So 2x minus 21296 over x squared. It's the same derivative as the previous problem, if you're wondering about that. And then you set this equal to 0 and solve for x. So to do that, we're going to move this term to the right. 2x equals 21296 over x squared. We're going to clear out that bottom by multiplying both sides by x squared. So you end up getting 2x cubed equals 21296. Divide by 2. That number here. 10648. And then you undo a cube with a cube root. And it does work out perfectly. 22. Now that may or may not be the answer, but that's the critical point. So let's go back and look and see what it actually wants for that. So the dimensions, the tank with the minimum surface area. So that's XX and then Y. So to solve for Y, we've got to use this equation down here. So Y is really 5,324 over 22 squared. Which is 11. You will notice this pattern of the answers being like half or double. So it says to separate with commas. I guess this is what you put in. I don't really love that, but that's kind of what it's saying there. Any questions on that?
I don't think so.
Okay, this one's a little bit easier. It's in some sense. So there's another way to do this type of problem, which we haven't really talked about. When they give you an equation like this, you can just go and graph it
Okay.
and look for the peak or the valley. Um, or you can do what we've been doing, which is take a derivative, set it equal to 0, so on and so on. Um, so let me, is it okay if I graph this one, or do you want to see it by hand?
No, graphing's fine. That's perfect.
All right. So the biggest thing with graphing is to get the right window. You'll notice that it kind of tells you the window 0 to 45. That's the X value. Let me grab a snip here of this. So in all the previous problems, you actually could have graphed, but you'd also kind of need to see it by hand as well, potentially. So it reaches a maximum after 15 days. That's the first answer. That's why the graphing is so powerful when you can find the max. And then the percentage of people that are infected is 38.63. So you can see how helpful it is to just graph it, get your answers, and you're done.
That is very helpful. Let me just make sure. Oops. Okay, sweet. Oops. Okay. Sorry, it's making me log in again. Okay, so I'm not really sure what we should work on because I have good scores on all the tests.
Is the review open?
The review, I think oh, okay, wait, no, never mind. There's another one. That's my bad. Okay. There's 21 questions, so obviously we won't get to.
Sure. Yeah. Just go ahead and share your screen whenever you're ready. I'll let you know. All right, got it. Got it. Okay, got it. Some of these we'll be using the calculator for. This is an example of one of them. I got it. Got it. Got it. Got it. Right, got it. Right, got it. All right, do you have your calculator today?
Unfortunately, my roommate is borrowing it for a test right now, so I don't.
Okay, that's fine. Well, let's do one more. Let's see what 11 looks like. This is something totally different. Okay, so we'll just stick to like 1 to 10.
Okay.
All right, let's take a look here at some new problems. Okay, so some of these will be when you get to the test, when you get the test and see a problem like this, you're going to see multiple choice answers. And the way you would use those multiple choice answers is you will take the derivative. It'd be easier for you to take a derivative of these and see which of those gets you back to this one. Okay, because to do this one requires more advanced calculus than probably you're going to be comfortable with. But I'll show you. I'll show you. This is actually what's called an integration by parts problem.
Okay.
This is in calculus 2. So d, what's called dv is equal to 16x, and u is equal to the natural log of 5x. And what you end up having to do here is integrate both sides and then take the derivative of the right side, which becomes 1 over x. And then there's this formula, which says uv minus the integral of v du. So for u, you're just pairing these up. So your u is natural log of 5x, your v is 8x squared, minus the integral of 8x squared times 1 over x dx. So minus integral 8x dx. So you do have to integrate this, find the antiderivative. It ends up being 4x squared plus c. So this right here is your answer.
Okay.
But as I mentioned, when you see this on the test, you're going to take a derivative of this, probably is your best bet, and then hopefully you'll see that that becomes this up here in the problem.
Okay.
Yeah, let me know when you get that down, if you have any questions
Oh,
on
I
that.
did. Sorry.
Okay.
Sorry, I think my thing
Right.
glitches sometimes.
Okay. The next problem here, it says round. Whenever you see that, you're going to go right to your calculator. We were doing problems like this before, where you just put this into the calculator. It's the math 9 FN int.
Okay.
So let me go find a calculator to do this in for us. There's no reason to do it by hand. Um, okay, so this ends up being 2.4657. All right, so next one here, it tells you have to use integration by parts, which will be very challenging to learn. the this all the stuff you've done, it's just this is a pretty, I mean, it's hard for even calculus 2 students to do, but you have to take a derivative here. Du is 2x dx. V is 1/4 e to the 4x. And so you're using this formula uv minus integral v du, which you don't need to know where it comes from, but 1/4 x squared e to the 4x minus the integral 1/2 x e to the 4x dx. And so unfortunately you have to do integration by parts again for this. So u is going to be 1/2 x. dv is going to be e to the 4x dx. So du is 1/2 dx. V is the 1/4 e to the 4x. And then it's again that uv minus integral v du. In parentheses this time because of that subtraction there that you bring down. It's okay if you're not fully following, but
Okay.
this is what it is. 1/8 x e to the 4x plus, this is minus plus, integral 1/8 e to the 4x dx. And then this comes down as well. So now we can integrate this finally. And it becomes 1/32 e to the 4x plus c. Bring this down, and that is your final answer. Let me know if you have any questions about entering that into the calculator.
So when I'm entering it, like what goes after 4x on the
This one,
second one?
oh, sorry, plus.
Oh,
Yeah,
okay.
need an operator there.
Oh,
Yeah,
see.
I left that out. Whoops.
Okay, got it.
Next question here is calculator problem. So they give you some sort of function. They want to know the total amount accumulated in the first 2 days. You're going to find the integral from 0 to 2, 48 t e to the 3t dt. So you're basically grabbing this function and you're just integrating it from those two bounds, 0 to 2. And then from here, go right to the calculator,
Okay.
which I will do as well. Be good to get some practice on this.
Yeah.
We'll probably get another lesson in on this topic. Let me get this entered in. Use X instead of T. Why is it doing that? E 3x. So this ends up being 10,763.
Okay.
All right, next question. So this is, so in calculus 2, they talk about applications of integrals. This is the first one. They want you to revolve this region. So there's this curve y equals square root of x from 0 to 2. And the idea is if you were to revolve it around this axis, it would make this kind of maybe like a sideways vase or something, or I don't know, acorn nut or something. That's what it would look like if you could revolve it around the x-axis, a rotation. And if you've seen like a potter's wheel, it's kind of like that. So the volume here has a specific formula. It's integral from a to b pi r squared dx. So your r is this right here. That's r. It's really y. You can really think of it as y in the problem. So That's your R there. The integrals from 0 to 2, you often bring the pi out. Square root of x squared dx. Now, if you look here, it says type an exact answer in terms of pi. So if you put this part into your calculator without the pi, and you get a number, you will then just append the pi to it. So you don't put pi in the calculator. Just you're going to do that at the end with your answer. That's very important. That'll keep you from having some issues there. You can even, you don't have to square the square root. You can let the calculator do that. But this ends up being 2 when you're done. And then you put the pi with it. So 2 pi is your final answer.
Okay.
Okay. Let me see here. So this one you cannot do with a calculator because your calculator does not integrate E very well. But this one's really similar. It's pi, it's the same volume form, integral pi r squared dx from a to b. So it's from -1 to 2, -1 to 3, pi, and then this is your radius function again. So you end up squaring e to the x like that. Now, when you square e to the x, it becomes e to the 2x. It's not x squared, it's just e to the 2x dx. The antiderivative of e to the 2x is 1/2 e to the 2x. Bring the pi down, your value from -1 to 3. So it's always top minus bottom. You put that top bound in and then the bottom bound in. So this pi over 2 kind of just lingers on the outside. E to the 6, that's putting the 3 in, 2 times 3 is 6, minus e to the -2. And that is your final answer.
Okay.
The way to do this, if it were multiple choice, is you would put it in your calculator, and then each of the answers you would just put in the calculator to see which one is the same. Like this is some number down here. I have no idea what this is. Let's call it like 50 or something. You would just, your A, B, C, D, you'd put into the calculator and see which one gave you 50. After you do the calculator integration, like you're gonna use your calculator on the actual exam for all of this.
Right.
But these are not possible to do the way they want them. Okay. Next one here. So this time you got to know what this curve looks like. 25 minus x squared looks like this. Goes from -5 to 5. And you're revolving it around the axis again. So you're going around that way. So the volume is pi integral from a to b r squared dx. Your a to b is -5 to 5. This is your radius function. 25 minus x squared dx. So this part in blue is what you would put into your calculator. So polynomials, your calculator can always do polynomials, which is what this is here.
Okay.
All right, so I'm checking to see that the calculator will actually do this. And sometimes the answers don't mean much. This one ends up being 10,000 over 3 times pi.
Okay.
Okay. Next couple here. You tell me when we got to stop.
Let's do till 2:40 if that's okay.
Okay, so average value. This has a specific formula. It's from A to B, 1 over B minus A, f of x dx. You're again going to use your calculator. So it's 1 over 7 minus 0, integral 0 to 7, x squared minus 5 dx. So this goes right into the calculator. You do not have to do it by hand. I mean, you can, but why would you? So this ends up being 34 over 3, purely a calculator problem.
Okay, easy enough. Yes.
Sorry, I didn't hear you.
I said easy enough, I guess.
Yes, yeah. Okay, do you want to do one more here? Or I don't know what you got time for. Okay. So really similar average value. It's the same formula as what we've been using. It's 1 over 24 minus 0, integral 0 to 24, square root of x plus 1 dx. You will again go to your calculator. I assume this will work. The square root might be a slight problem. I'm not using a TI-83 full disclosure. I'm just using some other software that I use for this.
Okay.
But we can always clarify whether that it would work or not. So this ends up being 31 over 9. Kind of magic how that works.
Perfect.
Is that good for today or
Yeah.
more? Okay. All right, we'll go ahead and stop here.